Welcome. So if you came here to attend ARC 216, you're in the right room. If you came here to attend something else, you're still in the right room. Stay here. Feel free to come up in front if you want. My name is Kaustubh. Most folks call me KD, simply just go by that. I'll be joined by Salil Suri, by Krish Sivakumar, and Mahmoud Rakab. And over the next 45 minutes, we will go through a number of different announcements and topics. In particular, Salil's going to talk about innovations and announcements in making our infrastructure portfolio richer for your use. Krish is going to talk about operations, automation, security, and compliance, and then we'll hear from a customer. Okay, throughout this event and throughout our interaction with you, you'll hear us talk about how we optimize for workloads, for your workloads. And we firmly believe that the best infrastructure is that which is finely tuned and optimized for your workload. There may be AI, ML workloads, modern workloads, other workloads that you have. And through this, we focus on core priorities of making this infrastructure reliable, of making this infrastructure secure, cost-efficient, simple, and sustainable. But the reason we embarked on the journey of cloud, and the reason Google in particular shines is because of the bottom piece, which is there's unique platform innovations that make our infrastructure shine. Those are around custom silicon that we build. It's around cloud systems that are built for scale, and around AI-driven automation that makes the lives of our customers, you all, better. But today, in particular, we're going to talk about 4 ways in which we help you run high-performance workloads, run them cost-effectively, leverage tools and automation to optimize your operations, and finally, safeguard the cloud through security and compliance. Okay? So to start with, and you'll hear this in the first section with Salil, there's this tension between uncompromising performance and cost. Running high-performance compute workloads are super important, but they're not always important for all workloads. There are workloads which need to optimize for efficiency, for cost, and we will talk about how our portfolio allows you to balance those trade-offs more effectively. The second piece is around running the cloud, optimizing operations, and we talk about a number of different tools that help you do that. Krish will cover these about FlexMix, future reservations, batch, and equivalent code component. And then finally, we have a very unique and differentiated approach to security, to compliance. Krish is also going to cover a number of different innovations in that space around confidential computing, assured workloads, and our unique approach to compliance. So lots to cover, so without further ado, I will welcome Salil up on the stage. Salil. Here you go. Take it away.
Can you guys hear me? Okay, live. Thank you for coming to our talk today. Thanks, KD. So as KD mentioned, we're going to sort of cover our compute portfolio and go deeper into the choices that are sort of available to you as our customers. So customers such as yourself, like I've had a few conversations since today morning, and like are looking to build modern new applications using the best that the cloud has to offer. But at the same time, you don't want to sort of forget traditional enterprise workloads, which for many of you form the vast majority of your IT landscape, right? So at Google Cloud, our mission is to purpose-build infrastructure to account for needs of all of your workloads. And our compute portfolio reflects that. So our general purpose offerings are designed to span a wide cross-section of workloads. Like I would hazard like up to 90% of the workloads that you have in your data center could be sort of classified as general purpose. And but we have a bunch of different offerings in there. And each of these offerings are designed to sort of give you some amount of optimizations balancing for cost, maximum flexibility, as well as extreme consistent performance. Our specialized VM offerings, on the other hand, are purpose-built to design to sort of give you maximum performance for a given resource type, and a resource type here being compute. So if you really need like a high clock speed like CPU, or memory, so you need like memory ratios, like really high memory for SAP HANA kind of workloads, or GPUs for your AI ML applications. And today, let me share with you some announcements that we're making and updates that we're making to our portfolio. First, the C family is sort of getting a makeover, right? So C used to be compute optimized. With the launch of C3 and its shift to general purpose, we are signaling its broad applicability to a broad cross-section of workloads, much more than what it before. This family is optimized for great performance and minimal disruptions to your workloads. And think of it as a great family for workloads that do not write any performance variance while running. We do all this while also delivering industry-leading storage and network performance, and we'll talk about that in the subsequent slides. You might be wondering, what is C family good for? Which workloads map on to C family? And like I said, it's for a general purpose offering, so it's a broad swath of your workloads. Typically, customers run end-user facing applications. These are applications which are revenue critical for your business. These are applications which are low latency, and they show up in the form of databases, caches, streaming workloads, network appliances, and such. CVMs are also the first set of VMs that are based on the newest elements of Google Cloud Titanium architecture. As you heard from Thomas today, hopefully some of you made it to the keynote, Titanium is our custom, purpose-built, dedicated hardware stack that offloads the CPU and provides performance, reliability, scale, and security improvements for your cloud workloads. This is great because this frees up the CPU to focus on customer workloads and maximizing the performance for customer workloads. The new Titanium architecture also comes designed to transparently handle infrastructure updates. So while we update our infrastructure in the background, there is absolutely zero disruption to your workloads, which is amazing. Google's new custom-built infrastructure processing unit, or IPU, which is part of our Titanium architecture, allows us to offload the networking from the host onto a dedicated network card, which allows us to sort of achieve like staggering results. Let's take a look at what our customer XSwitch.io was able to achieve. XSwitch.io designs an extremely high-performance Layer 3 switch designed specifically for broadcast media and financial streaming services customers. They were able to sort of achieve a 4.5 times improvement in performance, and they got up to 183 gigabits per second and 30 million packets per second out of a single VM instance. And we believe that we can go even higher, and we've seen numbers to that effect. Last but not the least, Titanium also enhances the security for your workloads because we are able to do line rate encryption and much, much more, enhancing the security profile of your cloud workloads running on our platform. Titanium has been underway for many, many years. Many of the products that you already use benefit from the Titanium architecture, but the newest elements of Titanium are sort of coming. We're bringing them to you in the guise of CVMs and hyperdisk. but this is going to be the foundation of all future Google Cloud offerings. So this is going to be the architecture that underpins all of it. With that, let's dive into C3. Google was first to market to bring general-purpose VMs based on Intel's 4th generation Sapphire Rapids processor. Built on the latest compute, storage, and networking innovations, C3 VMs offer up to a 35% better price performance than previous generation VMs, while the customers also get 50% faster access to DDR5 memory, as well as AMX accelerator, which is used for CPU ML inference and is 12x faster than the AVX 512 instruction set. But that's not all. C3 also, like I said, is based on the Titanium architecture, and we are able to not only improve the packets per second performance, we are also able to achieve 200 gigabits per second throughput for a single VM instance. This is 2x our previous generation. And for those of you who are not going up to that high in terms of network bandwidth consumption, we are also doubling the 2x standard VM bandwidth. So without opting into tier 1 networking, the standard bandwidth scales linearly depending on the size of the instance, all the way up to 100 gigabits per second, which is twice as much than you can get anywhere else in public cloud. And last but not the least, it gets even better with HyperDisk, because we announced HyperDisk last year. It's our next generation block storage architecture. It allows you to truly decouple storage and compute, and therefore allows you to maximize TCO savings for your customers and your workloads. With HyperDisk Extreme, we are able to deliver up to 15x higher IOPS and 8x higher throughput, which is in preview right now. That translates to roughly 500K IOPS per C3 instance, which is again the highest available to you in public cloud. So this is great, but we're not stopping with C3. I'm super excited to sort of announce our C3D offering, which is sort of right now in preview, based on AMD's 4th generation Genoa processors. C3D combines C family's enterprise-grade reliability and tooling with the significant boost provided by AMD's 4th generation Genoa processors. These are massive machines. These are up to 360 vCPUs, 2.8 terabytes of memory on a whole host. So which makes them great for sort of processing large data sets. And we have seen our customers are realizing anywhere north of like 45% gains, price performance relative to our previous generation AMD VMs. And we have seen great results on a wide variety of benchmarks, such as data processing, in-memory databases, relational databases, code compiling workflows. ARM. That brings me to ARM. And ARM is, so as I talk to customers, our customers are telling us that ARM is a great part of their infrastructure IaaS strategy, and they're adopting ARM increasingly. And as we do that, they're conveying their excitement to us. So today, we are super excited to pre-announce our upcoming C3A VMs based on Ampere processor. And we expect C3A to deliver 40% better price performance relative to comparable x86 instances in the market. C3A will be available in more regions with more features, with advanced networking, and will be enabled with up to hundreds of ISV applications right out of the gate. This should really allow you to sort of enable your workloads on ARM. And we have seen some good success with that. Dailymotion is seeing great results, and I think it makes for a very cost-effective solution. With these announcements, we have a complete C portfolio across Intel, AMD, and ARM, and we allow an enabled choice so you can choose what is best for you and your workloads. When we think about switching gears, when we think about making and the things that we need to do to make Google Cloud Platform a great place for researchers, scientists, such as yourself, to run your HPC workloads, we typically think about three things. First is fast and affordable infrastructure so that you get those TCO savings and you have the lowest time to complete your job. Second is easy and compatible. Our platform should be easy to use for an individual researcher as well as an HPC guru, right? And it should be compatible so that it allows us to sort of plug into all the partner offerings that we have out there. Third is partner preferred. We work very hard to enable a broad partner ecosystem, and that allows for us to expose that choice back to you as a customer. We are optimizing our infra capabilities across compute, storage, and networking. As an example, we recently announced, and this is in preview, our H3 VMs. H3 VMs are purpose-built for HPC workloads and offer up to 3x improvement in per node performance and up to 2x lower cost than our previous generation VMs, which is staggering. This benefits like a wide variety of industries, so from molecular dynamics to like weather forecasting to computational finance. Outside of H3, we are also making other improvements to make sure that you can run HPC workloads in a seamless fashion on our platform. An example that I would like to sort of call out is Parallel Store. So Parallel Store is a managed file system service which went into preview today, and it's built on the Intel Deos OSS stack. It provides extreme IOPS, like millions of IOPS. It provides extreme throughput, so you can think about like 100 gigabits per second measured at the maximum capacity, and extremely low latency. And it is 6.3 times faster read throughput performance compared to any other competitive like service offering available in public cloud today. So let's go a little bit deeper into H3. H3 offers industry-leading performance. I talked about per node performance going up by 3x and costs coming down, but we also do all this while maintaining high efficiency. For example, on a popular weather forecasting benchmark, we were able to demonstrate that we can go up to 4,000 cores, over 4,000 cores, keeping 90% efficiency, which is almost like double than the previous generations. We are extremely pleased to sort of partner with a wide variety of our ecosystems, so Rescale, Altair, Ansys, Total CAE, Parallelworks, to actually bring all of this innovation to you so that you can choose the best integration points for your HPC workloads. With that, let me turn it over to Krish to take you through infrastructure operations.
Thanks, Salil. So you heard about the breadth of the portfolio that we have with respect to VM families, and one that is actually built with a lot of your workloads in mind. It's not a one-size-fits-all, even though the general purpose workloads fit into our general purpose families for the most part. What we'll actually cover through in the next few minutes is really how do we manage that growing portfolio of VMs and the new families that are coming in an efficient, secure, and automated way. So we'll cover through a number of different topics as we go along that cover all the way from reliability to security and everything in between. So let's start with reliability. So a good VM portfolio really needs to deal with all of the different things that it needs to optimize for the workload, but at the same time, it really needs to be rock solid and reliable. So one of the things that we've been doing at Google Cloud is investing pretty heavily into node-level reliability. So when you think about that, you're really talking about firmware-level reliability, you're thinking about hypervisor-level reliability, and sort of overall machine-level reliability in total. So one of the things that we're doing is reliability at scale. We're very, very happy to announce that we have upped the bar on overall reliability for general-purpose machines from what used to be 99.5% to 99.9. So it's a 3 nines for all general-purpose machines going forward. And on top of that, for memory-optimized machines, we're sort of pushing the bar even higher to 99.95% reliability. So it's 3 nines out of 5 reliability going forward. So starting today, those two are going to be the new benchmarks on reliability that we have industry-wide. And one of the other things that we're doing here is providing you the information to be able to go ahead and then monitor the overall reliability and health of the environment. So within the console today, you now have built-in dashboards that allow you to observe the overall health of your environment in a very, very easy way. And of course, there are APIs available for doing that as well. And on top of that, we also add recommendations and alerts if there are issues that we actually find with respect to the overall reliability of the environment. So in total, we want to make sure that at the base reliability level, you have really large numbers that you could actually depend on and provide you the instrumentation that allows you to go ahead and then tackle any issues that happen even past that in a proactive way. Talking about proactive, any large fleet of anything for that matter, whether it's compute machines in a data center or large fleets of cars, they will need maintenance. And we want to make sure that the act of maintenance or lifecycle management does not really impact your workloads. So Google has been heavily investing historically, and even more so now, on a set of technologies that allow you to do live migration of your workloads. So customers such as Etsy and Aerospike use that pretty heavily in ensuring that their workloads themselves do not get disrupted as a result of the maintenance actions that Google takes. Live migration allows you to go ahead and then move a workload from one machine to another without disruption with memory transfer. So the data actually shows up and the computation essentially happens without any pause. On top of live migration, we also have live update, which allows the actions that we take for the software stack at the node level to be done without any disruption to your workload. So live migration takes care of, sort of anything that mitigates the movement of machines from one to another, while live update essentially does the in-place updating of your node software without disruptions. Between these two, we expect that a vast majority of what we do from a maintenance standpoint will actually be taken care of without any disruption to your workload. But on top of that, we're also providing mechanisms through which you would actually get much more proactive notifications for those situations. Let's say you've got a large SAP HANA database, or you're running a whole bunch of GPU-oriented workloads for your AI/ML jobs. We want to make sure that the overall notification period is long enough in such a way that you'd be able to go ahead and then take actions based on the fact that there is a future maintenance event that's coming in. And that's not the last thing. We also are looking to introduce user-triggered maintenance, which is really maintenance happening on your terms, on your schedules. So the collection of these capabilities then allow you to go ahead and then tackle fleet maintenance in a least disruptive way for your jobs. Moving from there, we also want to talk a little bit about flexibility of provisioning within your environment. So Flex MIGs, we're actually pre-announcing that here at Next. Imagine a managed instance group, which is a way in which you would actually have a set of homogeneous VMs at very large scales, hundreds, if not thousands, that could actually be deployed as one entity. With this new capability, we're introducing two dimensions of flexibility for these large managed instance groups. One dimension of flexibility is by VM family. So you could mix and match different VM families into a single managed instance group in such a way that you could go ahead and then optimize one part of that managed instance group for one type of workload from a price performance standpoint, and another part is a different price performance point, but all being managed as one group or one entity. The second dimension that we're introducing is really the consumption model. Today, when you deploy a managed instance group, it's either all on-demand workloads or all spot workloads, and neither shall the two mix. With this new capability that's coming in, we're actually allowing you to go ahead and then provide a mix of consumption models between on-demand and spot, which then allows you to optimize both on the availability and cost factors for your particular workloads. So this is going to come into preview shortly. I want to make sure that you knew this first here. Moving from there and talk about capacity, cloud capacity is elastic. When you need more capacity, you grow into it. When you have less needs, you just kind of give it in. Somebody else has got that need. They could actually use that. And that's kind of how cloud capacity works, and we all know that. However, there are situations where you have a critical business need, and you need to make sure that that cloud capacity is absolutely assured to be there for you when you need it. For an example, let's say your photo room and you've got a very large app rollout that's coming up, and you know that's going to happen in about a month's time, and you need to make sure that you're not just depending on the normal elasticity of the cloud, but you want to have a highly assured capacity available to you at that time. That's exactly what they do. Future reservations is the capability through which we'd actually provide you that high level of assurance for an upcoming workload burst that you might have in the future in your environment. This can be applied to a variety of use cases. Clearly, a future burst in workloads is a good one. Anytime that you have rare, supply-constrained resources that you want to have your hands on in some future time, that's an excellent place that you could actually go ahead and then use that too. You're moving into a new data center, and you want to make sure that that migration is going to be successful for you, and you know exactly when that move is going to happen. Use future reservations, and that allows you to go ahead and then apportion that capacity for you at no extra charge. So this is a capability that we're public previewing today that then allows you to go ahead and then go straight into the console and then create a future reservation for any new workload that's coming in that you need burst capacity for, sort of additional capacity for, fully assured for you. All of the capacity planning and the assurance is taken care of in the back end, and you're able to go ahead and then enjoy using this capacity at the time that you need for your most critical workloads. Moving from there, we want to talk a little bit about job management. How many of you were at the keynote and then heard the word AI and have a word count? Quite a few, right? So a lot of the AI jobs essentially end up being large batch jobs. So I've got a model training work that's going on, or I have some inference job that's going on. That's a lot of itty-bitty workloads that are all combined together to form one giant workload. What Google Batch allows you to do is to essentially act as a funnel, as a managed service that allows you that collection of workloads to be brought in into one entity, the Google Batch service, and then executed from there. We have a number of different partnerships that we've built over time and continuing to build and invest into, where whether it's life sciences, whether it's FinOps, whether it's core AI ML workloads, or any others, or HPC type of workloads, as Salil was talking about with the H3 VMs, you'd be able to go ahead and then bring all of those together into a single entry point that is fully managed for you from a job submission standpoint, from a job control, job notification, and job assembly perspective. So Google Batch is available in production for you to tackle all of those challenges as you go forward. We're also very excited to talk about a particular capability that is really, really sweet for developers. How many times did you have to actually go in and then do something in a console and just wished that you could simply automate the 15 clicks or 20 clicks that you did to go ahead and then take that one action? We're debuting equivalent code component that's available in production on the Cloud Console today that allows you to simply do exactly that. You're able to go ahead and then take a series of UI actions and have those UI actions parametrically convert into code that you could use right away. And that code would be available in a variety of form factors. You could use that as REST API, you could use that as Terraform, you could use that as our G-Cloud CLI. All of those are available for any of those actions that you would take on the console for a series of things. Developer's dream, because now I could take that one set of actions that I do on the UI and simply go ahead and then parametrically automate that to n number of times that I want to do, embed that in my scripts, embed that into my automation frameworks, and go from there. Moving from there, I want to talk a little bit about security and compliance. So today, Kevin Mandia and Thomas Kurian in the keynote kind of highlighted a number of different things that are happening from an overall security standpoint at Google. But here, in the next few minutes, we'll talk a little bit about some of the things that we're doing from a compute standpoint. The first thing is really about integrity of your environment. Confidential computing is not new, but what we're continuing to do with it is we partner very heavily with two of our major partners, AMD for their secure encrypted virtualization, or SEV technology, that allows you to essentially have signature-driven, hardware-controlled signatures that you could actually tackle at the firmware level and up above at the host software level that allows you to go ahead and then have a clear view of what that software is, any change that actually gets done for that software, and be able to secure that environment at the lowest level possible. We're also expanding that in the C3 platform that Salil talked about earlier with Intel's Trusted Domain Extension technology. Again, very similar from a hardware perspective that allows you to go ahead and then get that utmost integrity for that node going forward. So confidential computing. Compliance is a huge factor for many, many of our workloads, not necessarily for US government or some other governmental needs, but even for our industry needs, whether it's HIPAA, whether it's PCI, whether it's NEBS, or any other industry-level compliance. One of the approaches that Google has taken in this is not necessarily sequester or ask you to sequester your compliance-needed workloads into some corner like a GovCloud. We've taken a different approach in providing you the controls that you need on our regular data centers in such a way that you're not really operating with a smaller set of services on some sequestered GovCloud, but you're operating with the broadest set of services on our general purpose public cloud data centers with the right controls that you could actually go ahead and then apply to them. We're very proud to say that assured workloads, which is the mechanism through which you would actually do those controls, is now available in 9 regions today and is continuing to expand. This is the largest set of regulatory compliance workloads that you could actually deploy in any public cloud today. And the number 9 is today, and like I said, it continues to expand as we go forward. This provides you a view in terms of the variety of compliance regulations that we invest into, both in terms of industry-wide privacy and governmental and sovereign requirements that we deal with across. So you will see a number of different global ISO standards that we actually comply with today at the infrastructure level, and a number of specific country or jurisdiction-specific standards that we comply with as well. And this list is something that will continue to grow. So from an operations, automation, and security standpoint, we continue to invest pretty heavily into ensuring that you could go ahead and then utilize Google Cloud in the most efficient and cost-effective way as possible. With that, I would love to invite Mahmoud, who is representing Snap. He is the engineering manager at Snap that is responsible for the infrastructure. Mahmoud?
Thank you so much. Let's see how this works. Okay. Hi, everyone. My name is Mahmoud, and I'm an engineering manager at Snap. And today I'll quickly give you an introduction on how we at Snap work with the Google folks to try to figure out how we use all those machines and instance types. So my team, I lead the infrastructure team in Snap, and my team work with a lot of Snap engineers that run different workloads. Some of them are reverse proxies, some of them are stateless services, some of them are data intensive or machine learning workloads that requires a lot of computation. And then I work with all these teams to try to figure out what is the right instance types for them to use. How we do this, we usually try to experiment and measure as much as possible because every use case is different. So we try to work with them, especially when there is a new machine type that comes out. We try to run it on an A/B test it and run it on different machine types and see if the performance is getting better or getting worse and so on and so forth. And then there's some general guidelines that we've learned by working with Google for a long time. For example, C types are very good for high computation use cases, but also use cases that requires stable performance, if this makes sense, versus maybe a more general N types that are also high performance, but does not have this strong, consistent performance. Machine types like T machine types are good for certain workloads that require specific CPU to memory ratio, for example. And then there is always the performance versus cost trade-off, right? Sometimes you want to use the best machines out there, no matter how much it's going to cost you. And in other cases, you would try to save cost as much as possible without compromising performance. And I want to talk about like 2 use cases here that look similar, but also like they have some differences, and tell you how we go about like picking the right instance types for them. The first one is our API gateway. Those are like front-end fleets that sits around the world, and they talk to our customers right away. So all the Snapchat users talk to those API gateways. And those are like reverse proxies. They receive HTTP requests. They do some maybe encryption, some validation, and then route the request to the right backend service. And as you could imagine, those are very compute-intensive use cases, but also the important part is it requires a very consistent performance, because we don't want to provide different experience to different users. And in those cases, machine type like the C machine type that has performance consistency is very important to us. Another use case would be the machine learning. Those are also like backend services. They run feature extraction, training models. So also very, very heavy on computation and requires a lot of CPU. But in this case, we might be able to like not really need this performance consistency in order to be able to save cost. And for these use cases, for example, using something like the instance types would be very beneficial, because it might be cheaper. And the last thing I want to add is this is a continuous process that we always work with the Google engineers as more machines comes out. For example, when the C3 came out and we like tried to test it, we saw as high of a performance improvement as 20%. Looking forward, and I want to tell you, like, this is my last slide, so I want to tell you what my team do working with Google like on a regular basis, right? The first thing is capacity planning. As you mentioned about like future reservation is like one thing that you could use. In Snapchat, for example, we have like some, like if there's like a very popular event, usually like around New Year's Eve, we know everyone is going to pull their phone and start taking pictures of fireworks, for example, right? So if you know ahead that there's going to be a traffic surge, you could try to estimate it and try to work with Google or using future reservation to be able to make sure that you have enough capacity that you need. The other 2 things, I think those are the things that I talked about, trying to find the right balance between performance, reliability, and also cost. So if you have like a background services or a service that would run in the background, does not need a lot of performance, so you'll have to use like a cheaper instances types. Versus if you have something that is maybe user-facing, you want to provide consistent performance as much as possible, you want it to be as fast as possible, so you would use things like C machine types. There's also things like the planned maintenance. If you have use cases that cannot afford being interrupted, for example, in this case, you might look at service, instance types that would provide more predictable maintenance schedule. The last thing, failover. I think this is also very important. As much as I would like to think of the cloud as elastic and has infinite resources, in practical, this is actually not the case. And there's been a lot of cases where we try to scale using a certain instance type, and there's just, we run out of them. There is not more of them, right? So you also, when you're designing this, you have to think about, okay, if I'm using S3 and there is no more S3, what am I going to fail over to, right? And the last thing you want to do is to fail over to a machine type that is drastically different from your main machine type, because now you're having 2 different hardware running your service, which might just completely like make you reason about like things like latency very hard, right? Because some of them are going to be slow and some of them are going to be fast. And it's going to be almost impossible for you to figure out that the problem is coming from having different hardware, right? So trying to figure out what kind of instance type you want to fall over to in case if you run out of your instance type is also very important. That's it.